Aluminum number 3 wire is not quoted in aluminum pricing because it is not a standard wire size for aluminum conductors. The standard aluminum wire sizes are number 8, number 6, number 4, number 2, number 1, number 1/0, number 2/0, number 3/0, and number 4/0. These wire sizes are based on the American wire gauge system, which is a logarithmic scale that defines the relationship between the diameter and cross-sectional area of a wire. The American wire gauge, abbreviated AWG, is a standardized wire gauge system used predominantly in the United States for the diameters of round, solid, non-ferrous, electrically conducting wire. The gauge number increases as the wire diameter decreases. This relationship comes from the processes used to draw wire. Wire is produced by drawing it through successively smaller dies. As the wire is drawn, its cross-sectional area decreases and its length increases. Since the volume of metal remains constant, a smaller diameter requires a longer length. High AWG numbers denote smaller wires and consequently higher electrical resistance per unit length. Therefore, when choosing a wire, the ampacity and application matter significantly. Ampacity refers to the current carrying capacity of a conductor, usually expressed in amps. It is the maximum amount of electrical current a conductor can carry before it overheats and potentially damages the wire insulation or surrounding materials. The ampacity of a wire depends on several factors, including its size, material, insulation type, and the ambient temperature. Larger diameter wires have a greater cross-sectional area, allowing them to carry more current without overheating. The material of the wire also affects its ampacity. Copper and aluminum are the most common conductors used in electrical wiring. Copper has a higher conductivity than aluminum, so it can carry more current for the same size wire. Insulation is a crucial factor in determining the ampacity of a wire. The insulation material provides a barrier between the conductor and its surroundings, preventing electrical current from leaking or short-circuiting. Different types of insulation have different temperature ratings, indicating the maximum temperature they can withstand before degrading. The ambient temperature also affects the ampacity of a wire. As the temperature increases, the wire's resistance also increases, reducing its ability to carry current. Therefore, the ampacity of a wire must be derated for higher ambient temperatures. The National Electrical Code, or NEC, provides guidelines for determining the ampacity of wires based on their size, material, insulation type, and ambient temperature. The NEC tables list the allowable ampacities for various types of wires in different conditions. These tables are essential for ensuring that electrical wiring is safe and reliable. In addition to ampacity, voltage drop is another critical factor to consider when selecting a wire size. Voltage drop refers to the decrease in voltage that occurs along the length of a wire due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The amount of voltage drop in a wire depends on several factors, including the wire's length, the current flowing through it, and the wire's resistance. Longer wires have a higher resistance, resulting in a greater voltage drop. Similarly, higher currents also increase voltage drop. To minimize voltage drop, it is essential to select a wire size that is large enough to handle the current without excessive resistance. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. Feeders are the conductors that supply power from the service entrance to the branch circuits. Branch circuits are the circuits that supply power to individual loads such as lights, outlets, and appliances. To calculate voltage drop, you can use the following formula: voltage drop equals current times resistance. The resistance of a wire can be determined using tables provided by wire manufacturers or in the NEC. These tables list the resistance per unit length for various wire sizes and materials. In addition to ampacity and voltage drop, other factors to consider when selecting a wire size include the type of load, the wiring method, and the environmental conditions. Different types of loads, such as motors, lighting, and heating equipment, have different current requirements. The wiring method, such as conduit, cable, or open wiring, can affect the ampacity of the wire. Environmental conditions, such as temperature, moisture, and corrosive substances, can also impact the wire's performance and lifespan. The number 3 wire size is not included in the American wire gauge system because it is not a commonly used size for aluminum conductors. Aluminum conductors are typically used for high voltage applications, and the standard wire sizes are sufficient for these applications. Aluminum wire has several advantages and disadvantages compared to copper wire. Aluminum is lighter and less expensive than copper, making it an attractive option for large-scale wiring projects. However, aluminum also has a lower conductivity than copper, meaning it cannot carry as much current for the same size wire. Additionally, aluminum is more prone to oxidation, which can increase its resistance and reduce its conductivity. To mitigate the effects of oxidation, aluminum wires are often coated with an antioxidant compound. These compounds help to prevent the formation of aluminum oxide, ensuring a reliable electrical connection. Aluminum wire is commonly used in overhead power transmission lines due to its light weight. The lower weight reduces the sag between poles, allowing for longer spans and fewer support structures. Aluminum is also used in some residential wiring applications, particularly for large appliances such as electric stoves and dryers. However, due to its lower conductivity and potential for oxidation, aluminum wiring requires special installation techniques and connectors to ensure safety and reliability. When connecting aluminum wire to other types of conductors, it is essential to use connectors that are specifically designed for aluminum. These connectors are typically made of aluminum or a bimetallic material that is compatible with both aluminum and copper. Using the wrong type of connector can lead to corrosion and a poor electrical connection. The National Electrical Code provides specific requirements for the installation of aluminum wiring. These requirements cover topics such as wire size, insulation type, connectors, and grounding. Following these guidelines is essential to ensure that aluminum wiring is installed safely and reliably. If you are looking for pricing on number 3 aluminum wire, you will need to contact a specialty wire manufacturer or supplier. These companies can provide you with custom pricing for non-standard wire sizes. Non-standard wire sizes are typically used in specialized applications where the standard sizes do not meet the specific requirements. For example, a non-standard wire size may be needed to achieve a specific voltage drop or to fit within a limited space. Specialty wire manufacturers can produce wire in a wide range of sizes and materials to meet the needs of their customers. They can also provide custom insulation and coatings to protect the wire from environmental factors. When ordering non-standard wire sizes, it is essential to provide the manufacturer with detailed specifications. These specifications should include the wire size, material, insulation type, and any other relevant requirements. Providing accurate specifications will help the manufacturer to produce wire that meets your exact needs. In summary, aluminum number 3 wire is not a standard size due to the American wire gauge system and its typical use in high voltage applications with established sizes. If needed, custom manufacturers can produce this size, requiring detailed specifications for proper fabrication. Remember to consult the National Electrical Code for safe and compliant wiring practices.